Breakthrough. New research reveals how hurricanes shape the coastal landscape in the Everglades. I'm Steve Belair. Welcome to Breakthroughs. That hurricanes can create sudden and dramatic changes to the landscape is obvious to anyone who lives along the Gulf of Mexico's coast. They are powerful, high-energy, destructive forces that can flood homes and fell trees, and can leave a lasting impression on all of those affected by them. However, less discussed are the modifications they make to unpopulated regions, such as the Florida Everglades National Park. In a recent paper published in Proceedings of the National Academy of Science, researchers from different universities, including LSU, examined how Hurricanes Wilma 2015 and Irma 2017 fertilized the Florida coastal Everglades, paradoxically facilitating mangrove wetlands recovery. Mangrove wetlands are a critical component of the coastal landscape because they are highly productive, absorbing damaging winds and floodwater from hurricanes, sequestering carbon that otherwise would be released into the atmosphere and contribute to the climate change, and providing habitat for many species of economic importance. As a plant, mangrove trees need nutrients such as phosphorus to grow along the coast. However, the Everglades have a limited amount of this key nutrient, unlike Louisiana soils, which are high in phosphorus due to the nutrients traveling down the muddy Mississippi River. According to Victor Rivera Monroy, co-author of the study, this is because the Everglades have different geology and hydrology than other areas of the Gulf of Mexico, causing phosphorus limitations, and as a result, low plant and algae productivity. These conditions make the coastal ecosystems oligotropic, which means nutrient limited. The researchers analyzed surface soil and plant nutrient concentrations from 2004 to 2018, comparing storm deposits from Hurricane Irma and nutrient inputs across mangrove sites. They found that hurricane-induced mineral inputs increased the amount of phosphorus present in the soil and observed by the mangroves within an area that stretched up to 6 miles, 10 kilometers inland from the coast. This fertilization was cumulative over several years as hurricanes impacted the area and extensively affected the mangroves. Irma and Wilma's storm surges, 12 years apart, mixed the waters and resuspended nutrient-rich sediment from the ocean floor, much like a gardener rakes topsoil. In addition to enriching the soil with phosphorus, this redistribution of sediment has the added benefit of increasing the soil elevation, which can help to offset sea level rise in certain areas. The researchers estimated the amount of soil elevation the mangroves would normally experience in a year increased by approximately 14.4 times due to the hurricane's storm surges. The environmental impacts of the hurricanes are a trade-off. While hurricanes defoliate and in some cases flatten trees, this input of phosphorus also gives the mangroves opportunity to regenerate. However, it's not an even distribution. It's not going to save the coast, but it's a significant change that makes a difference in the long term depending on the hurricane intensity and frequency, Rivera Monroy said. Wow, a little good from bad. I'll leave a link to the full article in the description, and as usual, please like, share, subscribe, and take care.